are you? Good. Nice to hear from you. We're going to talk about testing. Now, yesterday, I might have thought differently, but yesterday another speaker tells me that it's true because she read it somewhere. So testing. The example I want to use is the RPN calculator, reverse Polish notation. And so if we want to add 3 and 5, some calculators have equal signs, and you just type in 3 plus 5 equals. Reverse Polish doesn't have equals, and so you type in a 3, and it displays, and you type in enter, and it pushes the 3 onto the stack, and it stays in the display, but it's ready if you type another number like 5, the display now shows 5, and then when you hit the plus, it pops the 3 off the stack, adds it to the 5, gets 8, pushes the 8 back on the stack. And so for a fine demo, how about this? So we tap a 3, we tap enter, we tap 5, we tap plus. Oh, so impressive. Now, I will say, so this is an example from my book, I will say that one of the reviewers had to tell me that I had 1, 2, 3, 1, 2, 3 twice and no 4, 5, 6 line. So that's why we QA stuff. So what makes this work is the stack, and suppose we wanted to use tests to create the stack. So let's write a test. I need a name for my test. How many of you come from XCTest? So you're used to names like this? We can use shorter names than that. In fact, we can use really short names, like initially empty. And then there's a setup. For my setup, I'm going to create a new stack. And what to test? Well, we have a special word for that. We call that an expectation. And our expectation is that stack will be empty. And so there's our test. Now let's turn that into code. And with Swift testing, it's amazingly simple that this translates across. Test becomes @test, the macro. The name is just a function called initially empty. The setup, well, you know how to create a new instance of a stack. And the expectation that the stack is empty looks like this. If you run this test, the feedback is a little strange. And so even though we prefer to write things like this, we learn that when we do tests, we should do this instead. And you go, oh, no one would write like that. I know, but you get better results if you have the calculated result to the left of the equal sign and the expected value to the right of the equal sign. The feedback is just nicer, so, okay. I'd like to add some more information. For instance, initially empty is a fine name for a method, but when I'm displaying the results, I'd like something that's a little more clear, like a new stack is empty, and we do that by specifying the display name as a trait for the test macro. Ooh. I'd also like to say, I've got a bunch of different tests, and I'd like categories for them. In this case, this is a stack test, and I do that with something called tags. And so all this is available now, and so that is our first test. At its core, at its core, getting rid of the display name and everything, it's just this. Readable, understandable, it's just the test macro, it's the method name, it's the expectation. So that's a test. So we're done. Of course, there's more. But first, what's not there? And again, if you've done XCTest, what's not there is I'm not inside of a class that subclasses XCTest. I don't have long test names, and that's kind of nice. I don't have a setup and a teardown. I'm just in a standalone method right now, and all of those XCT asserts, assert equal, assert true, assert not nil, just pound expect. Pound expect, that's another macro. So we've seen 2 macros so far. Let's start with our existing test. I'd like to give it a little different name, and so that we can mess with it. It's called push stack. But before I do, let's run our test. A demo, Daniel? No, still in slides. Thank you. So here's my test. I run it, the expectation is true, and so the test passes. The test passes. I'm here first thing in the morning to wake you up. So let's go ahead and push something onto the stack. I've implemented this already. I'm pushing 10.3 onto the stack. And you'll notice I still am assuming that the original stack is empty. And so this is a non-mutating method. It returns a new instance of a stack. That's that push stack. And so I can expect that the push stack is not empty. So imagine we've implemented push. This is about testing, not the other stuff. And let's run it. And what's interesting is the first expectation passes. The second expectation passes. The test passes. That didn't look very interesting to you, did it? Well, check this out. What if we change the first test from being true to false, so it's going to fail? We run it. The first expectation fails, the second expectation still runs. An expectation does not stop further expectations unless it throws an error or something that would change the flow. A failing expectation is just a failing expectation. But the test fails because at least one of the expectations inside fail. So all expectations fail, and the asterisk is, unless an error is thrown or something fatal happens. So we have two paths to explore. Path one is, what if I want to halt when an expectation fails? That is a requirement, not an expectation. And so we take our expect and we change it to a require. Because a require could always fail, we have to do it with a try. Because we have something that could throw an error, we labeled our method throws. We run it. And this is interesting. This first one fails, but it's now a require, not an expect. So right away the test fails, and this second expectation is never executed. Okay? The second path is, what if we want errors? What if an error is a good thing? Like we expect this thing to throw an error. So let's write a test for popping an empty stack. I pop an empty stack. If this was objective C, I would probably return nil. But this is Swift, so I'm going to throw an error. So I have a stack. It's an empty stack. I try to pop the empty stack. That can throw an error, so I have to try that, which means I have to have a throws here. We expect this to throw an error. That's the good case. And so we say exactly that. We expect this to throw an error. If it does, that's a success. Now, I'm expecting to throw an error. I don't know what kind of error it is. Maybe sometimes it does throw an explicit error, and I want to test that it throws this kind of error. So I can be as explicit as you like. I can also have an expectation after that thing where it throws an error, and I run it. It does throw the error. It does execute the second expectation. It passes. So we're done. I have shown this slide already. And I'm showing it now because my next goal is to eliminate repetition. I have this initially empty test where I create a stack, and I have this push stack, and I have this repeated code. And maybe I don't mind it now, but by the time I have a bunch of tests that are doing the same thing, I want to organize these in such a way that I'm not repeating code. And I do that by introducing suites. A suite is essentially a struct around these tests. And so I have these tests with the repeated code, and I create a struct. This is already creating a suite for me. However, if I use the suite macro, I can create display names for it, I can put tags in it, and so we tend to put the suite macro here as well. And so now I can eliminate that repeated code and move it up into the struct itself. You think, uh-oh, I'm sharing state, and the answer is no, you're not. The way these run is really clever. It's as if you have one instance of the struct with the initialization of the stack in the first test, and you have a whole separate instance of the struct that has the initialization and the second test. They run independently of each other. And so this is kind of a nice little feature of suites and structs. By default, tests run in parallel. By default, tests run in random order. And so that you find sometimes that if tests always run in the same order, you have these dependencies that you haven't thought about. There are times, for instance, the display name, which is a reference type, and I'm using a shared instance of it, there are times where you do want the test to run in a specific order, and you can do that using serialized. So that's a trait that you can add to suite. When do you want to use serialized? Almost never, right? You want to use that default. So what about async? The law says we have to wait for it to return. So I have this method called ×2. Suppose it is async, and I want to test it. To test an asynchronous method, I have this test method called 2 times a number. I let my result be ×2 of 2.3. It is async, but let's forget about that for a second. I'm going to expect the result is 17. Now, I'm not an idiot. I know twice 2.3 is not 17. I expect this to fail. It's almost like I'm doing this on purpose. So I've got this ×2 that is async. I need to await it. It doesn't compile. And you know the error that it gives. It says an async method or an async call has to happen in an async context. And there's 2 choices, and we're going to choose the wrong one first. The first choice is I can take this async call and I can put it inside a task. It compiles, it runs, and the test passes. The test doesn't fail, let's say. So what happens? Let's put a print here down there because we're cavemen, and that's how we debug things. And now let's run it, and if you've done anything with async, you know that whatever is in that closure that's passed to the task is being run somewhere else by the system. It's no longer in our control, and immediately the line after the task is executed. And I print here into the console. And then I exit my test, and nothing failed, so it must have passed. Just kind of cool. And completely false. Because the expectation hasn't run yet. It's going to take a while for that await to return, and the problem is, by the time that that expectation is executed, it's somewhere else, and our method has completed and returned, and there's nothing to tell us, hey, you had to wait for that guy. So that's why we have to use strategy 2. And strategy 2 says, make 2 times a number async. Don't put it inside of a task. The test runner will take care of this. The test runner knows that if you're calling an async method, it has to somehow bundle it up. Now if we run it, we try to await ×2. That takes a while. After a while, we get our result back and we assign it to result. We run our expectation. We're still in scope, so our expectation fails. Our test fails, and then we print here, and this is pretty nice. So that's how you test async things in Swift testing. This is a failing test. Now, that's good. That's what I wanted to demonstrate to you, that when it passed, interesting things weren't happening. But sometimes you have a failing test, and you know you haven't implemented the code yet to make it pass. You know it fails. And so Swift testing says, well, we'll let you wrap that with something that says there's a known issue here. I know this stuff is not going to pass. And so now when you run it, it skips it. It says there's a known issue. I'm not going to even bother. Kind of skips it. What do you mean it kind of skips it? You'll see. But why not, excuse me, why not comment the test out? Well, Suppose the problem gets fixed. Usually somewhere else, but just because you guys are good at multiplying, I'll fix it right here. Run it. I get an error because it says, hey, there's no issue anymore. And this is wonderful, because how many times have you been fixing one problem and inadvertently fixed another problem, and this lets you know, hey, that test that you were skipping because things were bad, it's not bad anymore. So I just love this feature. So the issue is gone, so the test fails, so we get rid of our await with known issue, we run it again, and the test passes. Now what would you pay for Swift testing? Okay. I'm awaiting times 2. The called function is async. It takes a while. Maybe it takes a long while. And when you run your tests, you just don't have all day. Turns out there are strategies for this. One is you can set a time limit. You say, look, I'm going to set a time limit. If this thing runs for more than a minute, something's wrong. Now, this is in minutes. And you guys want to use Swift testing for what it's not intended to use. And you go, well, I want to do performance testing. Swift testing doesn't do performance testing. Oh, sure it will. Let's use a quarter of a second and test it. It's got to be a whole binary integer. It's only a whole minute. You're trying to use it for what it's not for. If you want to do performance testing, you want to do UI testing, you have to use XCTest. And you can mix XCTest and Swift testing in the same test suite. So this is really designed for, this thing is taking way too long. It's not a performance test, but I can't spend that kind of time. The other thing you can do is you can just skip a test. You can say, look, it takes a long time, and I want to just be testing this part of the system, and so you can disable a test. You can add a trait .disabled, and then it will skip the test. Another thing you can do is you can tag the test, and you can use the tag, say, long running, and you have different test plans, and some of the test plans run all the tests, and some of them run all the tests that aren't long running, and so that you can take your long running tests and run them less frequently if you like, or overnight if you like. So we're done. Well, if I'm showing the slide again, you know I've got more on eliminating repetition. Parameterized tests. This is so cool. So the additive identity says if you take a number and add 0 to it, you get that number. I'd like to write that, but I can't. I can test adding 0 to 5, and so I can expect if I add 5 to 0, I get 5. And I can add 0 to -7 and test that if I add -7 to 0, I get -7. And then I type 1,000 more cases like that. And it's really tedious. And I think, well, what about edge cases? There aren't really edge cases here. But 0 plus 0 or something else. Oh my God, is this boring? We use parameterized tests. What I'd like to do is capture what I said before and say what I really want to test is that if you give me an x and I add x and 0, I get back that x. Wouldn't that be nice? Yes, they say. Doesn't compile. You haven't told it what x is. I'd love to be able to say, well, you just choose some x's. Swift testing says, well, we can pass in some arguments, and we run it, and it expands it, excuse me, and runs it like this. And remember, it runs it for 5, it runs it for -7. What I want you to remember is it runs it independently. And so you get independent results. It might pass for one of them, but not the other one. For instance, suppose instead of, on the left side, add x to 0, you get x. What if I incorrectly wrote add x to 0, you get 5? One of these would pass, one of these wouldn't. And it's nice to see which one does. So this is kind of nice. Now, why did I take time to tell you it's like having a suite where they run once and they run the other way? Well, suppose I want to extract the arguments. The first thing you might try is this. You'd be wrong. But I was wrong. And I couldn't think about why, but it's because if you think about how they execute, samples can't be a member of additive identity, the instance. It has to be a member of additive identity, the type, so that I can get one instance where the value is 5 and one instance where the value is -7. And now this is pretty clean. And once you've done this, you can add in random values. You can say, look, let's add in some random samples. I'll get an array of doubles. I'll choose some random values. I'll return those, and now I'll run both the samples and the random samples. What I like about this is inadvertently, by choosing some random ones to throw in there, you'll find one that fails, move that over to your stock set, so you're running that one every time till you fix it. And so random will sometimes find values that you didn't think of to test, and that's kind of nice. And so that's that. So that's my quick look through Swift testing. We created some simple tests. Along the way, there are a lot of macros. And so this requires Swift 6. The macros we use for @test, @suite, @tag. You saw tags. You create the tags with an @tag. #expect, #require. It's a lot of macros. And if you expand those macros, they aren't interesting in any way. Like there's some macros when you expand, like #preview or #observable, or I'm sorry, @observable. You expand it and you go, oh, I see what they're doing. With this, it's just stuff so that the test runner runs right. And so it's not that interesting. We tested simple code, code that throws errors, code that is async. We organized our tests using suites. We organized them using tags. We took a quick look at parameters. And of course, there's more. Thank you.
Thank you, Daniel. Let's get started with a bit of questions. We have 2 questions here in the front and 2 mics running around. Up here.
Thank you so much. Great. I'm glad I didn't read into this yet because this is the first time I learned about Swift testing. So
and you were quoted.
Yeah, that was me, wasn't it? But, no.
For those of you that didn't know who was asking, the snort kind of gave it away, didn't it?
1 second. So I had a question. 1 second, because I can't stop.
Anna Beltrami.
Sorry. My question was with parameterized, when one of the tests fails from the values that you put, how does the failure show up? Is there helpful or confusing?
So what you see is when the test runs, you see the report, a single line for each one, and you see an X next to the one in the test report, in the test navigator.
Nice.
The other thing you should know about parameters is maximum of 2.
Good to know.
And so for my add one, I might want to then say, okay, let me also do add and subtract. And then I can have those operations as another parameter. If I want a third parameter, I have to cheat it somehow. I have to use a zip or something to get it down to just 2.
I see.
And then I can also use zip or some other way of combining things to get the inputs and the expected result and run those tests. So when you have 2 parameters, you run every element of this parameter with every element of this parameter. So you have
nice, awesome. Thank you so much.
Good. We had another question over here.
And then we're back.
Hello, thank you for the great explanation. I would like to ask whether it's possible to run Swift testing tests from the command line, because it was possible with XCTest.
So you can. It happens to be much easier for packages. For packages, you just run Swift test. As you might know, for XCTest in those, you have to specify what the device is, what the simulator is you're running those tests on, and so the command is a little uglier. The other thing you can't do yet from the command line is you can't filter by tags. So you can't say only run these tags. Excuse me, they recognize that that's a problem and they're addressing it, but that's the only restriction I know right now from the command line.
All right. Thank you a lot.
Yep, we have a question down there.
By the way, this is brand new, and they are expanding Swift testing in some interesting ways and getting feedback from the community. And I found this team to be very responsive. So if there's things you want to see, do let them know. They've been very responsive.
In the case of running with random parameters, I guess that it shows the value that failed.
Yes.
Is it possible to just rerun with that value, or you need to write a specific test case for running?
So that's why I said what I do is, as soon as I see one that fails, I take that value and I move it into the values that are static. So I make sure I don't lose it, because if you run it again, it's going to choose different random values. So I move it inside. There are testing frameworks for other programming languages that do this a lot nicer, and they do random till they find testing ones, and then they sort of narrow in on the ones that fail. We don't have that yet.
Yep, over there.
Could you share maybe what does expect does under the hood? How is it implemented?
No. It's not that interesting, because you can see it. If you type in #expect, you can expand the macro and you can see it. It's just not interesting because it's mainly things for the test runner. So I'm not trying to give you a hard time. It does what you think it does. It's like an XCT assert. What's nice about it is it knows the type of the values on either side of the double equals, and so you don't have all those different ones, and so that's kind of nice. Oh, also, let me just say, I had #expect and I had #expect throws. You think of those as differently, because #expect throws says, I am expecting this to actually throw an error. And if you have a #require with the throws, or a #require, if it doesn't throw, you can use the value that it returns and then do your subsequent expectations using that value, and that's kind of nice.
Thank you.
Did you get that? I didn't. I'll come ask you the question after. Chris?
Great talk, thank you. Was there anything very unexpected, well, very surprising that happened when you tried to use this framework? I've not used it yet. Like, are there any pitfalls that we'll run into, all of us?
So one of the things that surprised me turned out to be a bug that they fixed, and that was serialized. I had a bunch of serialized tests, and they weren't running in order. And then I finally realized they were running in alphabetical order. And so now they run in order of, so they did fix that. So far, no surprises that they haven't fixed.
Yeah, over here.
Hi, thank you. I noticed when you extracted the parameters from test function with the parameters to a property, it was a static property. And the function, as far as I saw, is an instance type. So I wonder, is it a syntax sugar to avoid capital SL dot that property, or is it somehow?
It kind of is that. What's happening is you're now running it, say, 3 times or 2 times, and it's as if you're running it one time with this actual value and one time with this actual value, and so it's extracting it and then creating an instance of that. But the set of all of them, the array of all of them, belongs to the type, not the instance, or you'd be in trouble, because you go, well, which one did I use last time? So it has to belong to something that isn't the specific instance of.
Yeah, I'm just curious. I think if I use it in other instance that I create, like in a function of instance function, if I use something static, I think it won't compile, because they will ask me to write capital self dot and that property.
So this is some of the magic of you're actually running it inside a suite, and you're running it with an @test. So that is some of the macro magic going on there.
Yeah, I have a question over there.
Hey, thanks for the talk. So I'm kind of struggling to like wrap my brain around the require thing, like in terms of when I would want to use that versus expect, because like, you know, when is it so severe you want to halt execution of everything else?
So for instance, I want to get a value. If I'm not able to get the value, I can't continue and use that value. So if I use a pound require, it says, hey, if this method doesn't return something that you want, if it throws an error, you can't even go on. Now, once I know that it does throw an error, I write a test for that, but it's the cases where it doesn't. So pound require says, otherwise, if you have a pound expect, it goes on and does all the rest of the expectations. Pound require says, look, if this doesn't work, just stop. You've got to fix this thing first.
Yeah.
It helps focus you, I think.
But it would like, you would think that that scenario would sort of throw like a fatal error anyway. Like the test shouldn't be asserting that this is a key like initialization.
Oh, careful how you're saying that.
Well, I mean,
This actually came up in the class where people said, well, instead of using that expect throws or require throws, why don't we just do a try? And if it throws an error, it's because you get more information and you get more control.
So I mean more like, shouldn't that be in the actual business logic and not in the test? Like, for instance, let's say with your stack example.
So the other thing is, I know I just cut you off.
That's fine.
But the other thing is, it depends how you're writing your tests. If you're writing your tests before that code exists, right,
Sure,
then you're actually, that requirement is a requirement, and that's going to inform the way you write your logic. If you're writing your tests after that logic, then I can see why you're saying it your way. So it depends if you're doing a TDD, or as everyone here knows, my HDD, which is, of course, hate-driven development. But if you're doing tests first, then you're actually catching it. Like, I don't know if you saw in my push example, my test specified exactly what that push had to do, that it was creating a new instance, that it was, and all that. So if you're doing tests first, I would argue for what I'm saying, if you're doing tests later, I can see your point. Does that make sense?
Yeah, makes sense. Thank you.
Thank you. I think.
I'm never going to give a talk that goes short again. There's so many questions.
Yeah. It's like you don't have that much experience.
Yeah.
Yeah. Final question down there, and then we'll let you off the hook.
Didn't you just hear me say I don't want more questions?
Sorry.
Wow.
Given that Swift testing is heavily based on macros and that are known to impact compile times and because they use Swift syntax.
I'm going to cut you off too. If you write your own macro in your own code, then you have to include Swift syntax, and that slows down compile time. If you're using macros from Apple's code, they get to cheat. So for instance, pound preview is a macro. You don't feel that slowdown of using Swift syntax because it's built in. It's the same thing with these. You're not feeling that pain of Swift syntax because it's built in if you're using Apple's tools. Does that make sense?
Yes.
So in general, you're right. If you write your own macros, right now it's very painful if you do a clean build and then you build again. It adds almost 30 seconds to the build to go through Swift syntax. You're not feeling that here.
Perfect. This was the question, and basically it's using the Swift syntax from the toolchain, basically.
Yes.
Thank you.
Yes.
Thank you. Thank you. Daniel, thank you so very much.
Thank you.